All right, welcome to the final part of our velocity versus time graphs lesson. Whoop whoop, last part. Okay, so this last part is on what the area under a velocity versus time graph means. So what does it mean? Okay, well, I gave you the answer already. The area is equal to the displacement, and I'm going to prove it to you with some good old dimensional analysis. So remember, your area under a curve is really the area of the shape of that curve. So I've got this nice block right here because my velocity is flat. It's staying at 10 meters per second for 5 seconds. So my area makes this nice square shape. I'm doing my best to draw a nice neat square. Ta-da! It wasn't perfect, so I'm going to erase it. Anyway, a square gets its area calculated by doing base. Oh, now it's still working. Oh well. By doing base times height. So if I want to find the area under the velocity graph, I just need to take the base of this square times the height of the square. So you might be wondering, how do I find the base and the height? Well, easy. Your base is just how much time has gone by. So according to this graph, 5 seconds have gone by. And then your height is just your velocity during this whole time. Ta-da! My velocity during this whole time, according to my graph, is 10 meters per second. So if I want to find my area, I'm going to take my base and multiply it by my height. So my base is 5 seconds times my height, 10 meters per second. Now, hopefully, you remember our unit analysis lesson where we talked about how you can cancel units. If you do, then you know right off the bat, seconds can cancel out. If you need a little refresher, remember when in chemistry you learned dimensional analysis and you learned that you can write 5 seconds as a fraction by throwing it over 1, and 10 meters per second is writing it as 10 meters over 1 second. And when you have units that are in the numerator and the denominator, they can cross cancel. It's the same thing here. So when my seconds cross cancel, what I end up with is 5 times 10 meters, which is really just 50 meters. What? 50 meters? What the heck does that mean? Well, meters is a unit for position. It's also my unit for displacement. And if I really think about what I've just done, I've really just done a dimensional analysis problem where I've figured out how far did an object go in 5 seconds. If it was going 10 meters per second, it's going to go 50 meters. Which kind of makes sense. If it goes 10 meters every second, it was going 5 seconds, that's 10 meters. Times 5, which is 50. I think I'm just saying all the same things over and over again, but you get it, you get it. Anyway, finding my area got me my displacement during that time, so let's use this skill to problem solve. So right off the bat, I'm going to do an example, but before I get started, I have to correct a typo. This should say from 2 to 8 seconds, from 2 to 8 seconds. You got it? Good. Okay, so let's find the displacement for this graph from 2 seconds to 8 seconds. So 2 seconds to 8 seconds is referring to this portion of the graph. Da 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 da. Lovely. So I want to find my area of that square by doing my base times my height. Now, luckily, this is a coordinate grid, so you've got little blocks that you can count just to double check your math. I wish I did this the first time I made this video. This is my second attempt, but that's okay. That's okay. So let's get started by figuring out what my base of my rectangle is. So I'm going from 2 seconds to 8 seconds. That means this is a length of 6 seconds long. My height is kind of weird because I'm going from, what is this? This is 0 meters per second. All the way down here to negative 5 meters per second. So what does that mean the height of my rectangle is? It means that it's a negative value. What? You can have that? Well, when we're talking about vector quantities that have direction associated with them, absolutely. So we're not talking about true geometry where you're finding actual areas, and area has to be positive. We're talking about quantities that are vectors in the real world, meaning that they have a direction associated with them. So that -5 meters per second is relevant. I have to include the negative to show that this object was moving in the negative direction for 6 whole seconds. I can't ignore it. It's very serious. Anyway, now that I've got my base and my height, I'm going to multiply them to find my area. So 6 seconds times -5 meters per second is going to mean the seconds cancel out, which means I have 6 times -5 meters, which becomes -30 meters. That's right, folks. My displacement for these 6 seconds was -30 meters. And yes, I can have a negative area because, once again, this is a directional quantity. This is displacement. I need to know what direction my object was displaced in. So if you ever get negatives, what I want you to remember is this small little reminder. Don't forget direction. It matters. That's what makes physics different from math. It's what makes this different from geometry. Our negatives have significance, and it is the direction that the object moved. That being said, let's try another one. So we're going to find the displacement now from 2 seconds to 10 seconds. Bum, bum, bum. So we know that 2 seconds to 8 seconds is this part of the graph right here. And we know that that part of the graph already has an area of -30 meters. So that's good. So if I wanted to find 2 seconds to 10 seconds, I'd have to add this part of the graph as well. From 8 seconds, I'll label it, to 10 seconds, right here. So if I were to label the height and the width of this rectangle, first of all, my base is going to be from 8 to 10. That's a base of 2 seconds long. My height is going to be 1, 2, 3. That looks to be 3 meters per second tall. And I don't like that 8 right there, so I'm getting rid of it. And I don't like that 10 right there, so I'm getting rid of it. It looks sloppy. There we go. So now that I've got my base and my height, I can figure out the area of that little part of the graph by doing base times height for that little part. So I'm going to do 2 seconds times 3 meters per second. And my seconds cancel out. Skadoosh, skadoosh. And then I end up with, oops, that was sloppy, and I don't like sloppy. Erase that. Then I do 2 times 3 meters, and that would get me 6 meters. And it is positive 6 meters, mind you, positive 6 meters. So what does that mean? I've got my 2 little areas now, but I want to find my total displacement. If I want to find my total displacement, I need to add up both of the areas. So I'm going to have -30 meters plus positive 6 meters. When I combine these 2 areas with their signs included, I end up getting a value of -24 meters. So what does that mean? This is my total displacement from 2 to 10 seconds. This is the sum of my 2 areas. And it includes direction, which is why it has a negative value. All right, so that was our 2 examples. I'm going to let you try this last one. This is the last problem of the notes. Cherish it. Okay, go ahead and unpause when you're ready to check your answer. All right, I'm assuming if you're listening to this, that means you're ready to check your answer. So hopefully, to find the displacement from 0 to 2 seconds, you started by finding the area from 0 to 2 seconds. So first things first, for this little block or rectangle, I'm going to figure out what is my base. And my base is 2 seconds. And my height is 1, 2, 3, 4, 5, 6, 7 meters per second tall. So to find my area, oops, that was ugly. I'll fix it. Try again. To find my area, I'm going to do base times height. And I just found that my base is 2 seconds And I just found that my height is 7 meters per second. My seconds cancel out. And my area is 2 times 7 meters, which is just 14 meters. This is a positive 14 meters because my velocity is positive, so it's going in the positive direction. So of course, I should have a positive displacement. Da, 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 da. That concludes the try, and thus the last problem of the notes. Congratulations, you made it through all 3 parts. You're right.